Hello, good morning, good afternoon, good evening, everyone. Welcome to our webinar, Modernize Your Industry 4.0 Architecture with Unified Namespace, ISA95 and MQTT Sparkplug. I'm Jayashree Hegde. I'm moderating the webinar today. It is my pleasure to introduce you to our speaker for today, Kudzai Mediteritsa. He is the founder of Industry 4.0 TV. Kudzai, a very warm welcome to you. Joined by Kudzai is Ravi Subramanian, Director of Industry Solutions at HiveMQ, and Gaurav Suman, who is the Director of Product Marketing. So Gaurav will be helping with the Q&A, moderating the Q&A. So before we begin the session, I would like to share a couple of housekeeping pointers. This webinar is being recorded, and the recording will be shared in a follow-up email. If you have any questions during this session, please submit them in the Q&A pod. We will take them up during the Q&A session. It will be at the last in the last 15 minutes. And please do not use the chat pod to ask questions, because it will be difficult for us to answer and moderate them. Lastly, there will be poll running at the end of the session, so kindly participate. So without further ado, I will hand it over to Kudzai. Kudzai, you're on mute.
Okay, thanks. Thank you so much for the introduction, Jayashree, and thank you to all those that are in attendance today. Okay, so today I would like to talk to you about how to modernize your Industry 4.0 architecture with the unified namespace ISA95 and MQTT Sparkplug. So for those of you who are not familiar with who I am, my name is Kudzai Mediteritsa. I'm a technology communicator and the founder at Industry 4.0 TV. I'm currently involved in 4 efforts, which is Industry 4.0 research. I do some educational videos. I also have got an IIoT podcast, and I also do some IoT system integration. I've got a background in embedded systems design, software engineering, and industrial automation. Okay, so now before we dive deep into the technical aspects of modernizing your manufacturing system architecture, we've got to talk about why manufacturers need to strive to achieve a lot size of one capability, right? So in today's global business environment, one of the most important challenges that are faced by manufacturing organizations is that the demand by customers for products that best suit their individual needs keeps on increasing, right? So what that means is that more and more people and businesses prefer customizing their orders when making purchases from manufacturers in order to suit their individual or organizational needs. So this could be customizing your furniture, your car, your clothing, or even industrial equipment, right? Now, as a matter of fact, industry analysts are predicting that the next decade of innovation in manufacturing will be driven by the demand for mass customization. So to put it as simply as possible, manufacturers who are able to produce a product at low prices and with customer-specific characteristics as quickly as possible will have the highest competitive advantage on the market in the coming decade. And so the thing is, up until recently, this has been difficult to achieve because the existing manufacturing system architectures and information modeling technologies that exist offered no flexibility that could allow you to build self-reconfiguring systems that enable you to achieve the lot size one capability. Now, if there's anything that you are to take away from this session today, it is the fact that for smart manufacturing to live up to its promise of mass customization, all manufacturing systems need to be able to autonomously reconfigure themselves without having to stop production process to perform some configurations, right? And the good news is that the possibilities for capturing customer-specific requirements and producing customer-specific products have been opened by the coming together of old and new technologies, such as the unified namespace concept, ISA95 standard, and MQTT Sparkplug, which we're going to be talking about today. So let us go ahead and find out how these technologies complement each other to enable smart manufacturing. And by the way, throughout this talk, you will hear me use the term Industry 4.0 and smart manufacturing interchangeably. So for those of you who are particular when it comes to definitions of these terms, we're just going to assume that what I mean is one and the same thing. Okay, so first of all, let's talk about why the unified namespace matters at all for smart manufacturing. Now, to truly understand why a unified namespace matters for smart manufacturing, let us take a step back and look at the interconnection that exists in traditional manufacturing systems, or what you would call Industry 3.0. And this is important because the interconnectedness of systems determines how flexible the entire infrastructure is to self-reconfiguration, right? So in a traditional manufacturing system architecture, you'd typically have your control applications running on devices and machines that are connected to a controls network. And then you'd have your high-level applications, such as your SCADA, connected directly to these devices, as you can see on the slide here. Right now, this sort of internetworking is deeply problematic when it comes to building smart manufacturing systems for a number of reasons. Okay, so the first challenge would be the data acquisition pattern that is used with traditional architectures in manufacturing. And to explain that concept, let's take, for example, a SCADA system that is used to monitor and control a production process. So in this scenario, you'd have your plant floor devices equipped with sensors that are fetching data representing the current state of your process. And the type of communication that is used between these devices and your SCADA application would be a request and response pattern of communication. So what that means is that your devices are always waiting for the SCADA communication engine to sort of like send a request via that direct link that they have together. And then the devices would then respond with the data representing the current state of the production process. Now, this creates a tightly coupled system because what it means is that at any given moment, all components of your manufacturing system need to know about each other's physical presence in the form of IP addressing, and they also have to be present on the network at that particular instance of time. So in a way, your systems is coupled in both space and time, right? And that works if all you're concerned about is keeping your factory running and being productive in a sort of like a self-contained manufacturing environment, right? Now, but if you need to integrate every other aspect of your manufacturing value chain, from your top-level strategic management processes to your cloud-based artificial intelligence workloads to procurement, shipping, and so forth, and frankly speaking, it will be difficult to perform this kind of wide-scale integration because it will be sort of like impractical to manage such a huge set of addresses for you to be able to connect these systems together. Secondly, in most cases, this request response model is implemented using proprietary application interfaces that are only understood by device vendors, right? And this means that your application or your SCADA application becomes dependent on a particular device that it is controlling, right? So in essence, you cannot remove a device and replace it with a different device from a different vendor without having to provide some protocol implementation details or even writing some custom software scripts, right? Which obviously is a big problem because that is not a scalable way to approach this integration problem, right? Now, again, we understand that to achieve a self-reconfiguration, we expect that when a device or machine fails, you need to be able to plug it out and replace it with another one from a different vendor that performs the same functionality, pretty much how you'd exchange interuse your devices on your PC. You could plug in your USB mouse. You can plug in a USB keyboard without having to perform any sort of configuration. So what we strive to achieve with smart manufacturing is to get to that point where you're able to plug in devices without having to perform any kind of configuration at all. So to kind of summarize here, a traditional manufacturing architectural approach is not suitable for building smart manufacturing system because it results in systems that are hard to integrate, they're hard to manage, they're tightly coupled, and more importantly for Industry 4.0, those systems are not scalable at all. Now, what would be a more suitable architectural approach to building smart manufacturing systems would be to employ a hub and spoke model for interconnecting your components or nodes in your manufacturing system. So this is whereby, in contrast to the request response pattern of communication that is typical of Industry 3.0 systems, the participants in your hub and spoke network, they never contact each other directly, right? Instead, they publish this information about themselves to a central repository of information, right? And that central repository of information is what you'd call a unified namespace, right? And then from there, other participants in your network can go on to pull that information that they're interested in from the unified namespace. So for example, they say you've got a shipping component that is interested in being notified when the production status of a particular ordered item reaches a certain stage, right? So what it would do, it would simply subscribe to the unified namespace, and that information will be pushed down to it whenever that event of interest occurs, right? So technically, all direct communication is totally removed, which makes it easy to merge your shop floor with every other system of your manufacturing value chain. So this architectural approach enables you to build a lot size one manufacturing system because it results in a system that is self-aware, right? And what do I mean by a self-aware system? Basically, what we're saying here is that when components at the edge of your network publish events as they happen to a central repository, that central repository can use those events to sort of like build a unified model, right? Or in simple terms, a complete picture of what's taking place at any given time or at any given location in your entire manufacturing infrastructure. And nothing happens in your system without the unified namespace knowing about it. So as a consequence, any component that is subscribed to the unified namespace would be empowered to reconfigure itself in alignment with the goals of your current production process, as it will be constantly having that real-time snapshot of everything that is happening at any instant in your entire manufacturing infrastructure, from your supply chain down to your shop floor, right? And we know that that ability to self-reconfigure is fundamental to building manufacturing systems that can produce a lot size of one. Okay, so now we understand conceptually what a unified namespace is, it being a central repository of information, right? But technically speaking, how would you go about implementing a unified namespace? So in the context of manufacturing, a unified namespace is a middleware solution, right? That allows you to collect data from various industrial systems, add context to the data, transform it into a format that other systems can understand, right? And one of the ways that you could implement a unified namespace is to use an MQTT Sparkplug based network architecture, such as the one that you can see there on the slide, where you have your MQTT Broker as that central repository of information, right? But we'll come back to this picture in a bit. For now, I want to introduce you to another technology standard, which is the ISA95. Right, so as we briefly discussed, a unified namespace is an architectural approach for interconnecting nodes or components that exchange messages in a smart manufacturing infrastructure, as it were, right? However, the unified namespace doesn't specify what sort of data objects are exchanged by these interconnected nodes or components. So this is where there's a possibility to then use ISA95 as complementary, right? So let me explain how that works, right? So before we actually go to explaining that, I want to bring to your attention this diagram, which many of you might be well familiar with, right? So based on ISA95, most traditional manufacturing systems were built around this hierarchical system architecture, right? And that has, to some extent, created a misconception that this hierarchical architecture is the definition of ISA95, right? So ISA95 is not an architectural standard. This architecture that you're looking at on the slide is just one of the ways to implement the ISA95 standard. As a matter of fact, ISA95 is a functional modeling standard that is used to define the interface between control functions and other enterprise functions, right? So to kind of get that out of the way, here's what Dennis Brendel, one of the original authors of the ISA95 standard, had to say in a recent article, right? So he says, even though it is not imposed by the ISA95 standard, one traditional implementation of ISA95 functional model into a physical architecture is a pyramidal network and system architectural structure, right? And then he goes on to say, can the concepts of ISA95 that have been well understood and accepted in industry be used in the context of Industry 4.0 or smart manufacturing? Yes, by simply replacing the hierarchical pyramidal with the networked activity model that is also defined in the ISA95 Part 3 standard. So this idea that Industry 4.0 architectures that employ a networked activity model, such as the unified namespace, are a replacement for ISA95 couldn't be further from the truth. So as it turns out, the unified namespace architecture and ISA95 are actually complementary to each other, meaning that you could design your smart manufacturing system based on the unified namespace architecture and then use the ISA95 standard for modeling the data object that get pushed around in your unified namespace, where all of your manufacturing system components are subscribed to, right? And the benefit here is that you get to use an innovative and modern way of organizing your components of your manufacturing system with the ISA95, with the unified namespace, in conjunction with the tried and tested functional modeling standard, which is your ISA95. Now, in order to really understand how that could work, I think we need to spend a bit of some time here understanding what ISA95 really is and how it actually works. So as industrial engineers and architects, which I believe most of you in the audience here are, we all know what goes on inside a factory floor to produce the desired goods, right? We understand why things like SCADA, DCS, and PLCs exist and how they exchange information in order to keep the factory running, right? And similarly, manufacturing business executives who are responsible for strategizing understand how businesses systems on the top floor work. They understand how logistics systems work to make sure that raw materials are delivered to the factory. They understand how to create orders and make sure that things are paid for. They understand that there are trucks that are needed to take the finished product away for delivery and stuff like that. Now, however, there's a whole set of activities that go on in the middle between your top floor and your shop floor. And these are not as clear-cut as you'd like them to be, right? And these activities include coordinating the personnel, the equipment, the materials to get the job done. And these activities also include taking requests from the manufacturing business executives who would say, this is what you need to produce. And then you go on to make that, and then you report back to the business to say, this is what was done and how many of these widgets were produced. Now, initially, this set of activities in the middle, right, which are in orange, they used to be represented or left out to what is called a manufacturing execution system, right? But it was discovered that the scope of activities that go on around there are much bigger than what could be achieved using or handled using an MES system. So back then, a team of experts decided to define something that was going to provide like a real solid interface between top floor and your shop floor systems. And this is how the ISA95 specification was born. So in short, the idea of ISA95 was to look at the activities highlighted above and try to identify common patterns in different manufacturing industries so that at least you could develop a model for exchanging information between your operations technology and your business systems, right? And that needed to be a model that could essentially be used in any manufacturing facility. So that's why that had to be an industry standard. Now, when that was done, what the patterns revealed was that those activities or processes that go on inside the manufacturing facility can be grouped into a different set of levels based on how much time it takes for a certain process to complete, and which resulted in this diagram, again, which many of you here are familiar with, right? Whereby we've got level 0, which is the physical production process, and we've got level 1, which consists of those systems that you put in place to sense and manipulate the process. This includes your field bus devices, your pumps, motors, and so forth. And then there are level 2 systems that use that information from level 1 to actually perform the control. So this could be your PID control or just your simple on-off logic type of control. And then we've got systems at level 3. So these are the systems that drive the workflows or recipes that cause the system to do exactly what it is that you want it to do. So which could be switching over to a new product or directing plant personnel to take certain actions, right? And then lastly, there are level 4 systems, and these are called business systems, and they are responsible for taking orders and determining what product is to be made, and what and how much raw materials are to be used, how much goods are to be produced, and so forth, right? Now, the next thing that I want to do here is to hone in on level 3 briefly, so that we could get an understanding of how ISA95 operates, because this level 3, as explained in a previous slide, this is the source of the ambiguity that ISA95 tries to sort of clear out and make sure that there is a seamless interchange of information between your top floor and your shop floor. So a lot of the information that is required to operate a manufacturing facility is handled at this level, right? So this could be through tools like your MES systems, or you could use some simple spreadsheets, warehouse management systems. Some companies use some custom software programs, right? And some companies also have the maintenance systems there existing in that level 3 systems. Now, in a scenario where we have got all these systems in place, there is obviously a lot of communication and integration which has to go on. There's a lot of exchange of information that happens there in level 3. And what ISA95 does is to define these activities as activity models. For example, you've got your production, your tracking, your dispatch, and execution. So these are all your activity models that go on inside your level 3 of your ISA95, right? Now, in addition to defining the manufacturing activity models, ISA95 goes on to define data objects that are to be exchanged between these objects, between these activities, right? So now this is where it gets interesting, right? Because these data objects that are defined by ISA95, they are implementation independent, right? In simple terms, what we're saying is that ISA95 is an abstract specification. It doesn't describe the data types or information models that can be used to create these objects. Also, it doesn't specify what transportation mechanism is to be used to sort of move these objects around. What it does is that it simply defines a standard terminology for what these activity models are, and it also uses UML to a representation for these data objects, right? So So this is where Sparkplug and the unified namespace comes in, because there's a possibility now to define the concrete data models from this abstract definition of ISA95 objects. And this is also an opportunity to use MQTT as the transportation mechanism in this scenario. Now, before I elaborate more on that, I want to set the context here, especially for some of you in the audience who might not be familiar with the MQTT Sparkplug. So I'm going to describe what it is and how it works. So I'm going to bring up this diagram again. So as I've already alluded to, the biggest hindrance to the advancement of smart manufacturing is that industrial systems have traditionally been, and even today, there still are, closed and proprietary, right? And we understand that without interoperability, there's no meaningful information that can be shared among the hardware and software components of a manufacturing facility. And we have standards like OPC UA that were developed to solve that problem, but the complexity of OPC UA has kept it out of the reach of most developers and software architects. For some of you that follow me on my YouTube channel, you'd be well aware that I've got an ongoing series on OPC UA, so you could attest to how complex that standard is. And in any case, I believe that OPC UA was built to solve an entirely different set of problems due to the kind of abstraction that it offers right now. But that's a topic for another day. So what is required in industry is a standard that is simple to implement, right? And it is with that in mind that the inventors of MQTT decided to come up with a specification for industry-wide interoperability that runs on top of MQTT, and they called it Sparkplug. Right, so Sparkplug is an open source software specification that provides MQTT clients the framework to seamlessly integrate data from your industrial applications, sensors, devices, and gateways, all within the MQTT infrastructure. And it does that in a bi-directional and interoperable way. And now Sparkplug does this by defining a specific topic namespace, right? As opposed to an open-ended topic structure that you typically use with the pure MQTT. For those of you that have worked with the pure MQTT, you know that you could actually come up with a topic and use it to publish information. So that would work obviously in an infrastructure where you've got a control, or you're not expecting to integrate anything else there. So everything is pretty much hard-coded, right? Now, what Sparkplug also does is that it defines a specific payload format, right? So that all components in your manufacturing infrastructure can interpret information in the same way. Because with your pure MQTT, there is no payload definition. So you could send a JSON object. Again, that would work if you are sort of operating in a closed environment where you do not have a problem manually connecting these systems, manually configuring these systems. But obviously that's a hard thing to do, because it's the pain when you need to integrate and when you need to exchange some systems. What you need to do is to have a system that enables you to exchange information that can be globally understood by all the participants in a SCADA infrastructure or your manufacturing facility, considering how big a SCADA network could actually get, right? And then now, because also in a SCADA environment, it's important to know the current state of any node or any component that is connected to your system. So what a Sparkplug does is that it also defines a session state management, so that you could have a way of knowing exactly what the current state as far as connectivity is concerned of all your nodes or components that are connected to your bigger manufacturing facility. Now, another important feature of Sparkplug is that when a new data source, so that it could be your device or your machine, joins the MQTT network, it can become immediately discoverable to other system components. And technically, when a Sparkplug device fails, you can replace it with another Sparkplug device which will announce itself as soon as it joins the network. And again, to emphasize here, this plug and play capability is really crucial when you intend to build self-reconfiguring manufacturing systems. Right. So what you see here is the structure of a Sparkplug topic pub. Right. So this is whereby your group ID is a logical identifier of for a group of MQTT nodes. So this is your MQTT client. This could be your devices or your machines. So your group ID is a way of logically grouping these together. So this could be like a site, or it could be like an enterprise. Depends on how you actually want to put those together. And we've got the message type, which indicates whether the message that is contained in that topic namespace is a command, or is it a process variable, or is it a debug to announce that this is a device that is joining the network, so it is announcing itself to the rest of the network, right? And then you've got your edge node ID, which identifies a specific MQTT node, and then you've got your device ID, which identifies a device that is attached physically to a node. So your device in this instance could be a situation where you have got some existing devices in your factory that are not capable of connecting to the internet, or if they are capable of connecting to the internet, they're not MQTT compliant. They're not capable of talking MQTT. So you could have your devices behind what you call an edge of network node, which is going to be responsible for translating those protocols and then communicating or pushing that information up to your Sparkplug broker or MQTT broker on behalf of all those devices that are not capable of doing that for themselves. Okay, now let us understand how Sparkplug helps to implement a unified namespace that uses ISA95 for modeling your data exchange objects. So bringing up this diagram again, you can see that Sparkplug uses an MQTT publish-subscribe architecture for the underlying applications transport layer, which decouples producers and consumers of data in an architectural fashion where the MQTT broker acts as the unified namespace. Also, because MQTT is based on push communication, what it means is that your industrial data is distributed instantly to all the business level systems. Your production, your supply chain, your shipping, and a whole lot of other systems within a manufacturing value chain that are subscribed to that unified namespace. And as I've already highlighted earlier, Sparkplug can be used to implement ISA95 specified objects for exchanging information between manufacturing system components, as it is essentially an exchange mechanism, right? So what it means is that Sparkplug can take data from one system, put it into an ISA95 format, push it to a unified namespace, and then other system components can pull it down in an equivalent format, right? And this is possible because Sparkplug has this capability of defining actual data, whether it's a float, it's an integer, or it's a structured value, or a complex piece of information. And what's more, is that Sparkplug allows you to build a generic data model, and then using that generic data model, build an asset, and then start to populate that asset with the information. Now, this is it's not something that is widely applied, to my knowledge, in the industry right now, but it's a possibility. And for those of you who want to find out how that might look like, you can check out what the University of Sheffield did for their smart manufacturing frameworks, common data structures, where they adapted information models that had already been defined by for OPC UA by inheriting the data structure and simplifying it for a Sparkplug, right? So that has already been implemented. So it's possible for you to actually use that Sparkplug models to capture the attributes of an ISA95 object, and then use it to exchange information around your manufacturing infrastructure. So the point here is that the same can be done for ISA95 objects using your Sparkplug payload, right? Now, using a Sparkplug architecture to sort of like map the ISA95 enterprise structure in a UNS architecture is something that is also quite powerful when it comes to integrating these two systems. So, as you might be aware, the physical components in a manufacturing facility are usually confined to a specific area, right? For example, you could have your PLC controlling a specific cell or your SCADA system on a specific site, right? So if you sort of like if you have like hundreds or even thousands of components in different manufacturing sites, all pushing data to your unified namespace, it can quickly become difficult to organize this information accordingly on the back end for visualization and all that kind of stuff. Now, as it turns out, ISA95 provides a convenient way of structuring your data sources in relation to their position within a manufacturing enterprise. And for that, ISA95 recommends this hierarchical format that you see on the slide, where you have your enterprise at the top, and you also have got your cell at the bottom. Now, Sparkplug sort of OPAS provides an opportunity to map this hierarchical structure using its topic namespace and its payload metric name, as you can see on this slide here. Right now, finally, in cases where you have multiple sites in different geographical locations that you'd want to gain total visibility on, then you could use a unified namespace architectural approach where you have an edge-based MQTT broker acting as a local unified namespace at each site, while it is connected to a central cloud-based MQTT broker through what you call an MQTT bridge, which a HiveMQ broker allows you to do. So as you can see on the diagram here, you've got your multi-sites with their own local unified namespaces, right? All pushing up to a centralized unified namespace on the in the cloud. Okay, so in conclusion here, we can see that the unified namespace architectural approach and your ISA95 functional modeling standard and Sparkplug specification do actually have a mutually beneficial relationship that could be used as a basis for building smart manufacturing systems to achieve a lot size 1 capability, right? So I think we'll be taking some questions here. But for those of you who are interested in finding out more about this, we do have a white paper that I put together, which you could download on the HiveMQ website. Okay, so I'll turn it over to you, Jayashri.
Thank you so much, Kudzai. It was a great presentation. Thank you so much. So before I hand over the Q&A to Gaurav, I will launch the polls. I request you all to participate. Gaurav?
Hi, everybody. Thank you, Jayashri, and thank you, Kudzai, for that fantastic session, fantastic presentation. So my name is Gaurav Suman. I'm the Director of Product Marketing here at HiveMQ. Just a couple of questions we have for you around the understanding you have on IIoT and smart factory. Where are you on your journey? If you could just let us know. We have a couple of questions. We'll give you about 30 seconds to answer these questions. So if you don't mind, please go ahead and cast your votes. And stay with us because there's a bunch of questions we have in the Q&A pod. Some we've answered live and several which we have waited until Kudzai finished, so I can lean on his expertise, and also Ravi, who's an industrial automation veteran who's recently joined HiveMQ, and we are super excited. You know, there's two very smart people from the industry 4.0 and industrial automation domain we have here. So I'm very excited about it. So bear with us. Once you submit your answers, we'll switch over to the questions we have waiting for Kudzai, you, and for Ravi.
Gaurav, you can take over the Q&A. You can start it. I'll keep the polls live so that people have time to cast their votes.
Sounds good. So I'm going to pick one which actually came in only a minute back. This is around Kafka, and it's an interesting one because, obviously the ecosystem is complex. There's more than just, MQTT involved here. And the question is from Stefano. And Stefano is asking if it makes sense to use Sparkplug or MQTT/MQTT in combination with Apache Kafka. Is there eventually an overlap? Kudzai, do you want to give your opinion on that, please?
Yeah, so actually, it's actually advisable and it's recommended. It's possible also if we actually do have a video that I did for Hive MQ, whereby we were actually publishing some MQTT messages from the a device on the field, and then using a Kafka extension that is inbuilt on the Hive MQ broker to forward that information to Azure Event Hubs, right? So Azure Event Hubs uses the same topic and same structure as your Kafka streaming analytics, streaming service. So it uses the same thing. So you could actually use those two in conjunction, whereby you are publishing your Sparkplug information and then forwarding that over to your Kafka. So that's certainly possible and recommended.
Sounds good. The next one I'll pick is from, bear with me 1 second. Okay, it's from an anonymous participant here. And actually, you know what? Let's just give Stefano an opportunity. If Stefano wants to ask a follow-up, Stefano, if you like, we can give you the opportunity to unmute your microphone and ask if there's anything you want to follow up on here. Jeshvi, could you help me out with that, please? Stefano, if you like, you can unmute yourself and ask a follow-up if you want.
Stefano, I have unmuted you. You can unmute yourself and start interacting.
Hi, hello. No, just was a consideration that I had in a project where I was involved, and we are evaluating to add also Apache Kafka as a business stream process, but we are in a Industry 4.0 project, so we are the pub sub strategy of Kafka and MQTT just made me to ask this question if there is an overlap, but I appreciate a lot the answer. Thank you.
No problem, Stefano. And as Kudzai mentioned, there's a video that Kudzai has done which explains, streaming into Azure Event Hubs. So please check it out.
Perfect.
Right, the next
Thank
one
you.
Sure, you're welcome, Stefano. Next one we'll pick up is from Ikechukwu. Ikechukwu is asking about OPC UA and Sparkplug data objects. Can you imagine a scenario, Kudzai? Let me begin with you around, conflict between OPC UA data objects and Sparkplug data objects. Is there a real world scenario where these things might come kind of face to face?
So not so these two, so like as I explained in the video there, to say OPC UA and Sparkplug, in a way, they differ in the kind of abstraction that it offers. So with OPC UA, the kind of abstraction that it offers is that it's more of machine-to-machine kind of communication, right? Direct machine-to-machine communication. So the data model is meant to represent a particular machine, the design of a machine, right? Whereas with Sparkplug, the kind of abstraction that it offers, sort of like it defines the setup of your infrastructure, like how your devices are laid out, or how the information is spaced out within your local factory or something, not particularly for a specific machine or device. So these are two different kinds of data models based on that kind of analysis. But now, to answer your question, as I'm not really sure how what you'd like to understand there, but it's possible, again, to, as I explained with these guys from Sheffield, where they took some OPC UA information model. So they didn't want to use OPC UA, they wanted to use Sparkplug. But now they wanted to have some models that were already done. They didn't want to go through the job of actually creating models from scratch. So they took some models that had already been done using OPC UA, and then they used them with Sparkplug so that they can create a simple data model or sort of like simplify the way that this information is packaged and communicated. So it's certainly possible to reflect OPC UA information model within a Sparkplug, but I'm not too sure if the reverse is true.
Sounds good. Anything to add, Ravi?
Yeah, I think he Kudzai answered perfectly. Yeah, I
Okay.
don't have much to add on top
Sounds
of that.
good.
Thank
And
you.
I find this question very interesting. So I'm going to pick this one up, Praveen, and thank you. I know you're always engaged with the community, so thank you for showing up again today. So Praveen has a question around any supply chain and ERP systems which already implement MQTT or Sparkplug. And his point is that they usually used, rather currently they use mostly request response REST patterns, right? So how would you answer this? Ravi, can I start with you on this one? The what supply chain and ERP systems are implementing MQTT or Sparkplug?
Yeah, I think most of the systems that I've encountered are basically hardware devices. ERP systems, I think they are kind of starting to get into this, but I'm not sure if I can say ERP systems like SAP and others have completely adopted it. Kudzai, have you encountered any ERP or supply chain systems use this?
Well, no, not that I know of. Not that I know of.
Okay.
So if I may just ask though, I mean, just as based on what you explained, Kudzai, and I look at the ISA95 pyramid, I see there's multiple systems, the ERP, MES is on the top, the sensors, actuators, etc. are at the bottom. That's just a functional view of the whole system, as you explained. Now, these systems, for them to become sort of MQTT ready or Sparkplug ready, that's where when the UNS comes in, the UNS does that job. They don't have to get ready in any way of reconfiguration. The systems remain the same, but they're now able to feed into the UNS and benefit from the Sparkplug compliance, which we need to obviously model there and do some work there. But do the systems themselves need to be modified to that degree? Is there going to be manpower needed and functional effort needed on the part of the vendors also?
Well, so if a system, be it software, because within a Sparkplug infrastructure, there's two kinds of MQTT clients, right? So you could have your ERP or supply chain system, whatever, as an MQTT client. And with Sparkplug, there's two kinds of MQTT client that you could use. There's an edge of network node, which is typically your devices, your hardware, as you mentioned there, Gaurav, or was it Ravi here. And then you have your application node, which is mostly the software-based kind of node in a Sparkplug infrastructure. And you have your SCADA, which is typically a host, and then the other application node can be typically anything. So once you integrate that Sparkplug interface within your supply chain system or within your ERP system, there isn't much configuration that you need to do at all, because that already embeds the Sparkplug functionality. So it pretty much works like an edge of network node would function. So all the functionalities that you'd find with the edge of network node, you'd also find with your application node, all the automatic discoverability, all the ability to also discover other nodes within a system, pull them down, and see exactly where they are located within a manufacturing infrastructure is possible. So there isn't a configuration that you need to perform at all, even on software-based Sparkplug systems.
Sounds good. Thank you. Thank you for clarifying, Kudzai. There's another interesting question around the industrial processes per se, and the question is from Thomas Donny. The question is, does ISA95 apply more to continuous processes or discrete? I'm assuming they mean discrete part manufacturing. Any opinion on it? I would imagine they apply to both, because again, ISA95 is just a functional framework, right? It doesn't mean how you're configuring your production line.
Yeah, absolutely. So actually, that was actually the primary goal of coming up with ISA95. That was the biggest challenge when it was being put together, to say, how do we come up with a model that encompasses all industrial processes, be it a continuous process or discrete process. So that's actually the core of ISA95, to try and cover all the kinds of sectors that are present in the manufacturing space.
Sounds good. Ravi, any thoughts from you on this?
I agree with that. I think as long as we can implement this this standard, I think we should be good.
So what I also find interesting, Kudzai, is the idea of lot size 1 or batch size 1 is where you started, right? That's the holy grail of all this hard work. Now, does that, just the idea of discrete manufacturing, does that help you get more comfortable, confident with that idea? Small quantities, small batch sizes, many different kinds of products coming out of your line. In my mind, then it seems as if it's naturally lined up with, something which is, which is more, process manufacturing driven. It's just one closed loop in which you are doing, so many other activities. And now there are all these smart systems which have been kind of become more intelligent because of a unified namespace construct. And then all you do is just code it. And then next thing you know, you have a product in hand, right?
Yeah, absolutely.
Layman view.
Yeah, absolutely. So, well, actually, it turns out that obviously the kind of customizable items in most cases, like for example, that I gave is your car, maybe with your Tesla, you'd want to customize that. You want to customize your smartphone, you want to customize your shoe. So these are all some discrete components. So that's why mostly that lot size of 1 is more applicable in the discrete manufacturing.
Okay, makes sense. Makes sense. Thank you. Thank you for clarifying that. So let me see if Thomas wants to ask a follow-up here. So Jeshri, if you could just help me again, unmute Thomas, Donnie, and see if they have a follow-up here.
Sure. Give me a minute. Thomas, I have unmuted you. You can unmute yourself and start interacting.
Yeah, okay. So I guess the question would be, the ISA95 standard is somewhat new, maybe within the past couple of years. Can you illustrate an example of how it's been implemented in a discrete part manufacturing system?
Okay, so, well, I'm not sure if I understood you, but the ISA95 is not new per se, but it was created in the like initially, I think it was 1995 when the initial specification came out. So that's like over 2 decades ago. Like what has been happening is that they've been adding some functionalities incrementally up until the early 2000s. So ISA95 is not new as it were. And then as far as an example in a discrete process, I think maybe that would be something that we could follow up with you on that. This is something that would be sort of like difficult to explain within a short space of time that we have here.
So Thomas, we'll be in touch, but thank you for the question and thank you for the follow-up. All right, so let's move on to the next one I have here around. Bear with me 1 second here. I'm just making sure I pick up the most pressing question here. Okay, Cyril had a question which was pretty similar to. Oh, actually, no. This one is interesting. So Cyril is asking, can you give some reference on how ISA95 data can be mapped to Sparkplug B? Was that the code snippet you showed us, Kudzai, in your presentation?
Well, no, that was the mapping of the structure. So, like, as I think I mentioned it on the video, that to say this is what is possible, right? So this is to say you could do this, you could map that. So there isn't a reference because no one is to my knowledge, no one is doing it out there. So the idea here is to say these are the capabilities of Sparkplug. So it's possible for you to do that, for you to map that object, because it has been done before. We know that we've got an OPC UA companion specification where they mapped the ISA95 object, right? So where you actually have an exchange of information using OPC UA. So the mapping of ISA95 object has been achieved using other standards of communication, but it hasn't been achieved using Sparkplug, but it is possible. So it's just waiting for someone to implement it, because Sparkplug offers the capability for you to do that using its generic model. As I've already also given an example to say, the University of Sheffield Smart Manufacturing Research Center they actually implemented an OPC UA information model within a Sparkplug, meaning that that same information model that was for ISA95 that was implemented using ISA95, by extension, it's possible to take that and implement it using a Sparkplug as a specification. So Sparkplug is relatively new in the industry, so we hope to see more and more people actually taking that up and trying to implement it.
Awesome, thank you, Kudzai. This next one is from Ala Mahjoub, and Ala is asking, and it's great that you just based on your background and the number of specific or many industry players that you speak with so often, Kudzai, you will be able to give us a sense of the current degree of adoption of ISA95 across SCADA and DCS vendors. So what's your sense of how many or primary vendors who have started to adopt ISA95 in SCADA and DCS?
So I guess it's a matter of saying, because as far as I know, the ISA95 is the only functional modeling standard that really is prevalent, that exists out there, right? So I wouldn't know precisely how widespread it is, but what I know is that it is the only common standard currently globally, right? Because that's the most popular one. So I wouldn't know exactly how much of it is adopted, but that's certainly the only standard that exists. There might be some out there, but as far as popularity is concerned, the ISA95 is the most popular.
Sounds good. So let's do this. If you could again help me out, Jayashree, unmute Ala Mahjoub, and I want to make sure we are reading the question right here, and if they can explain to us what they are thinking here.
While we're doing that, I can just quickly add to what Kudzai said, right? So I know that when we talk about Sparkplug and implementation of Sparkplug, I know a lot of gateway manufacturers and other PLC manufacturers have adopted MQTT in general and have started to use Sparkplug specifically as well. So Ala, go ahead.
Yes, can you hear me?
Yes, we can.
Okay, the point is we have some mega vendors in the world of SCADA and the DCS. For example, ABB or Halliburton in the oil and the gas area, and there are a lot of other mega vendors as well, specifically in the energy and the utility industry, who are in the area of DCS and SCADA. Therefore, I know the ISA95 was invented a long time ago, but since then, I cannot recall specific vendors that they claim their adoption of this standard. Therefore, from a practical point of view, does it worth to consider using this standard for integration of the different layers from the enterprise level until the shop floor level, using this standard if we don't have specific products that comply with it? This is the reason behind the question.
Okay, so maybe to answer that, the idea here is that obviously with Industry 4.0, you're in most cases, you're working with brownfield systems, right? And as far as the modeling is concerned, it might not be widely adopted, or the ISA95, right? But there are quite a number of people out there who are using the ISA95 for their industrial system, right? So the idea is to say, how do we bring these existing systems up to Industry 4.0 without ripping and replace? Like for those who actually have a ISA95 installed, how do we bring them up without having to rip everything apart and starting from scratch? So the idea is not to say this is the only way that you could actually implement a smart manufacturing system, right? You could start from scratch and not use those ISA95 objects. But the idea is to say, what about those who already implemented it and are not willing to rip everything apart and start from scratch? This is what the Sparkplug offers, that kind of interface where you could interface with a system that is existing.
Wow, okay. Meanwhile, I saw a lot of adoption, for an instance, for ISA99, which is 62443, which is concerning the security and but ISA95, I don't know. I'm asking because of that. Okay, thank you. It is clear now.
Okay, thanks.
Great. Thank you, Ola. Thank you for the question.
Thank you.
I want to be respectful of everybody's time. I know we still have many unanswered questions, really good questions, actually. And what we will do is we'll be in touch with any questions which have remained unanswered here in the Q&A pod. So between Ravi, myself, and Jayashree, we'll be in touch. If we need to reference and tap into Kudzai's expertise anywhere, we'll do that as well. So I will pass it on to Jayashree. Jayashree, you want to close for us, please?
Yeah.
Thank you.
Thank you. Thank you so much, Gaurav, Kudzai, Ravi. It's been really great. And everyone can actually also reach out to our community forum. So our support team will also help you with answering the questions. So we'll be in touch. There will be a follow-up email where we will share all the links. So if you are just getting started with MQTT, we have the MQTT Essentials ebook. If you are just getting started with Sparkplug, we also have a Essentials ebook for that. We will share all those resources in the email. So we will be in touch. And you will receive the recording as well in the email. Thank you, everyone. It's been great.
Thanks.
It's
Bye.
a pleasure to have you all. See you all next time.
Thank you very much.
Bye-bye. Bye-bye.